Okay, here we are on the back side, and we have more factoring to do. Number 9, first type of factoring we check for, greatest common factor. 6 does go into 18, and so we're going to go ahead and pull 6 out. Leftover would be an x squared plus 3. And that cannot be factored anymore. So that one was a nice little one. Number 10, and there's a big ugly one. That one is going to look to me as factored by grouping. Remember, there is nothing in common. The first term has no numbers to give you. The last term has no letters to give you. Not a D2PS, not a trinomial. It is factored by grouping. And remember, in factor by grouping, do not ever rearrange the terms and do not combine the like terms. Just group, group, and group. Out of the first group, we can go ahead and pull out x squared. Leftover would be an x squared minus 9. Out of the second group, because that's negative, we have to pull out a negative, and 4 goes into 36, so we're going to pull out a 4 and an x. Leftover would be an x squared minus, in order to get, when we distribute, that positive, and we need a 9. Out of the last group, it's negative, and 5 can be taken out. Leftover would be an x squared minus 9. And again, in factor by grouping, all those have to match. And so x squared minus 9 becomes one of our factors. Guys on the outside, squish them together. X squared minus 4x minus 5 becomes our second factor. And we have a unique situation here where both of these factors, that's a D2PS, and this is an easy trinomial, can go again. And so we'll go ahead and break this up into x plus 3 and x minus 3. Okay, that's how I did that. And this we're going to have to need an x box. And our multiply will be negative 5. And our add will be negative 4. And it's going to have to be 5 and 1. And to get the negative 4 on the bottom, the 5 is going to have to be negative. So that works in our multiply, it works in our add, and now we could go ahead and say, all right, easy trinomial. X squared gets broken up into x and x, 1 with the minus 5, 1 with the plus 1. And none of those factors can be factored again, and so this one is finished. Okay, number 11. First type of factoring we check for, greatest common factor. 14 does go into 28, and because that first term is negative, we're going to go ahead and pull out the negative 14. We also can pull out an a squared, and we can also pull out a b. Left over. That seems to be the same first term up there. But remember, when you distribute, you have to be able to get it. So what do you have to need and multiply inside by so that you get that term? And the answer is a 1. Okay. The minus is pulled out, so this needs to be a positive. And it needs to be a 2 and an a and a b to the 4th. Close him up. And that factor cannot be factored again, and so this one is finished. Okay. Number 12, we're going to go ahead and completely skip. If you tried factoring it, there is nothing in common. It is not a difference of two perfect squares. It's not a trinomial. It's not factored by grouping. This is cube factoring for number 12, and we skip that topic. So we're going to skip that whole question and scroll down to the bottom 4. In 13, that's what we call factoring with a substitution. That's the one where we let that letter W equal the expression in parentheses. Okay, so this becomes a W, this becomes a W, and we end up with W squared minus 18W plus 45. And that turns it into a nice easy trinomial. We can X box. Our multiply would be 45, and our add would be negative 18. If we think of the numbers, 9 and 5 won't work. What about 15 and 3? To get a negative 18, both of them are going to have to be negative to get that negative 18, which is good because a negative times a negative is a positive 45. All right. So we're going to go ahead and factor this easy trinomial. Go right to the factors because it's easy. W squared gets broken up into W and W. 1 with a minus 15, 1 with a minus 3. And well, a lot of people stop here, but it's too early to stop here. We have to go back and undo our substitution. Take those W's back out and go back to our expression of x squared plus 2x. X squared plus 2x. So I'm just going to go ahead and really quickly rewrite this as x squared plus 2x minus 15 and x squared plus 2x minus 3. And those are both easy trinomials, and so we're going to have to go ahead and factor both of them. So one of our trinomials will have a multiply of negative 15, and at the same time add to 2. And our numbers will be 5 and 3, but 3 will have to be negative in order to get the positive 2. And so we'll go ahead and factor this. Because it's easy, we can go right to the factors. X squared gets chopped into x and x. One gets the plus 5. The other is the minus 3. And for the second easy trinomial, we need a new x box with a multiply of negative 3 and an add of positive 2. And we're going to go ahead and say the numbers have to be 3 and 1, except that 1 is going to have to be negative to get the positive 2 on the bottom. All right, it is again an easy trinomial, so we can go right to the factors. Break up x squared into x and x. 1 with a plus 3 and 1 with a minus 1. And none of those factors can go again, and so this one is finished. All right, number 14, first type of factoring we check for, greatest common factor. 3 does go into 48, and I see there's an x in common, so we're going to go ahead and pull out the 3x. Left over will be an x squared minus 16. And that, hopefully you're starting to have good math eyes, is a D2PS. And so we're going to go ahead and factor that. Bring down the 3x, 2 sets of parentheses. X squared gets chopped into x and x, and 16 gets chopped into 4 and 4. And none of those factors can go again, although a lot of people will look at this one a little bit longer at the end here because that is a difference. 4 is perfect. However, that does not have an even exponent on it, and so that one cannot be factored again. Number 15. First type of factoring we check for, it's greatest common factor, and there is a 3 in common. And so we are going to go ahead and pull out 3. Left over would be a 25 minus x squared. And good math eyes tell me that this is another difference of 2 perfect squares. So we'll go ahead and bring down the 3, 2 sets of parentheses. Square root of 25 is 5. Square root of x squared is x. None of those factors can be gone again. And that one's finished. Last one. First type of factor we check for is greatest common factor, and there is nothing in common. 81 has no variables, and the x to the 4th has no numbers or coefficients. So that is a difference of 2 perfect squares. So we're going to go ahead and break it up. Square root of x to the 4th is x squared. Square root of 81 is 9. And it looks to me like we'd almost be done, but right here, that's a D2PS again. Difference, perfect square, even exponent. So we're going to go ahead and drop this one down. Remember that sums of 2 perfect squares cannot go again, only the differences. And the square root of x squared is x. Square root of 9 is 3. And none of those factors can be gone again. And that one is finished. All right, hopefully that was a good review of all the types of factoring we learned in this packet so that when we have to use the next packet, we'll be on top of our game. All right, see you guys in class.